Hello students, welcome back to Future Foundation. Students, in today's class of vectors and 3D, we will see the intercept form of a plane. So let's start the class. Write down the heading intercept form of a plane. So let us draw first Cartesian coordinate system, that is x-axis, y-axis and z-axis, and mark x-axis, y-axis and z-axis and origin. Let's say plane meet the coordinate axis at A, B and C on x-axis, y-axis and z-axis respectively, and OA is A. Let OA be A, OB be B and OC be C, right? Then coordinates of A will be A 0 0, coordinates of B will be 0 B 0 and coordinates of C will be 0 0 C, right? Then let equation of plane be px plus qy plus rz plus s is equal to 0, right? If this plane is passing through A, B and C, then coordinates of A, B and C will satisfy this plane. So if I put A0 0 in this, so P into A plus 0 plus S is equal to 0 implies P is equal to minus S by A. Similarly, if I put 0 B 0 in the plane having equation 1, then Q will be minus S by B. And if I put 0 0 C in 1, then R will be minus S by C. Okay, so from 1, now equation of plane becomes minus S by AX minus S by BY minus S by CZ plus S is equal to 0. If I divide by minus S, then X upon A plus Y upon B plus Z upon C minus 1 is equal to 0 or is equal to 1, right? This is called intercept form. Intercept form of a plane where A, B and C are called X, Y and Z intercepts respectively. Okay, now let us take some questions. Question is, if a plane meets the coordinate axis at A, B and C such that the centroid of the triangle is 1, 2, 4, then find the equation of the plane. So students, again if I am taking plane coordinate axis at A, B and C as is given in the question. So if I take A as E0 0, B as 0 B 0 and C as 0 0 C, so centroid will be E plus 0 plus 0 by 3, that is A by 3, B by 3, C by 3, right? We are assuming that centroid is this. Here equation of plane B, x upon A plus y upon B plus z upon C is equal to 1, right? We are assuming that this is the equation, right? Now, according to question, centroid is given, that is 1, 2, 4. So it is equivalent to a by 3, b by 3 and c by 3. So I can get a, b and c the help of this. So a by 3 is equal to 1 implies a is equal to 3. B by 3 is equal to 2 implies b is equal to 6. And c by 3 is equal to 4 implies c is equal to 12. So therefore equation of plane will become x upon 3 plus y upon 6 plus z upon 12 is equal to 1, or 4x plus 2y plus z is equal to 12. This is the required equation. Okay, now come to the next question. Question is a plane which remains at a constant distance p from origin, cutting the coordinate axis at A, B, C. First, find locus of centroid of triangle ABC, and second one, find locus of centroid of tetrahedron OABC, where O is origin, right? Now, in this question, we will use one concept additionally, that is distance of a point from a plane. Suppose this is a plane and here it is a given point. We want this distance PM. If plane is AX plus BY plus CZ plus D is equal to 0 and point B X1, Y1, Z1, right? Then PM would be mod of AX1 plus BY1 plus CZ1 plus D on root over A square plus B square plus C square. This is similar as in case of 2D when we find the distance of a point from a line. In case of plane, one additional axis is also there. Because of that axis, in denominator c is present, c square is present, right? Now according to question, let us go according to question. So again, this is Cartesian plane, this is x-axis, this is y-axis, and this is z-axis. A plane meeting coordinate axis at A, B and C as it is given in the question. Let's say coordinates of A, again A 0 0, for B it is 0, B 0, and for C it is 0 0, C. Okay. As a plane remains at a constant distance p from origin, so also p is equal to mod of, let equation of plane be ax plus by plus cz plus d is equal to 0. X upon a plus y upon b plus z upon c is equal to 1, right? Now according to question, distance of this plane from origin is p, so mod of 0 plus 0 plus 0 minus 1 upon root over 1 upon a square plus 1 upon b square plus 1 upon c square is equal to p, as coefficient of x, y and z are 1 upon a, 1 upon b and 1 upon 0. So by squaring both sides, it will be 1 upon a square plus 1 upon b square plus 1 upon c square is equal to 1 upon p square. Okay, now this is the relation, this is the one relation. Now what we have to find in first part, locus of centroid of triangle ABC. So first let centroid be G for triangle ABC. Let's say it is alpha, beta and gamma, and also G will be A by 3, B by 3, C by 3. So alpha is equal to A by 3 implies A is equal to 3 alpha. Similarly, B is equal to 3 beta and C is equal to 3 gamma, right? So from 1 upon 3 alpha whole square plus 1 upon 3 beta whole square plus 1 upon 3 gamma whole square is equal to 1 upon p square, right? So 1 upon alpha square plus 1 upon beta square plus 1 upon gamma square is equal to 9 upon p square. Or if I replace alpha, beta and gamma y, x, y and z, then it will become x to the power minus 2 plus y to the power minus 2 plus z to the power minus 2 is equal to 9 times p to the power minus 2. Okay, this is the locus of centroid of triangle ABC. Now let centroid be alpha, beta, gamma for tetrahedron OABC. Also centroid be E upon 4, comma P upon 4, comma C upon 4 in case of tetrahedron, right? So alpha is equal to E by 4 implies A is equal to 4 alpha. So similarly B is equal to 4 beta and C is equal to 4 gamma. Therefore 1 upon 16 alpha square plus 1 upon 16 beta square plus 1 upon 16 gamma square is equal to 1 upon p square from equation 1, right? Or from relation 1. So this would be x to the power minus 2 plus y to the power minus 2 plus z to the power minus 2 is equal to 16 times p to the power minus 2. This is locus of centroid of tetrahedron with BC. So students, for today's class we are done. Let's meet in next class. Till then, bye bye. Take care.